Okay, here's a diagram that depicts the situation. We've got the first airport where this plane takes off south 29 degrees west. Okay, and it helps when you draw this sketch to maybe put some dashed lines, one horizontal and one vertical, to help visualize the bearing of the plane. Once it's traveled for 20 minutes, it changes its bearing to south 52 degrees west, creating this triangle. Now, how do we find the lengths of these blue sides? If it's traveling at 420 miles per hour for 20 minutes, 20 minutes is a third of an hour, 20/60. So a third of 420, that first leg is 140 miles. And then 2 hours and 20 minutes is 2 1/3 hours, or 7/3 of an hour, or 980 miles. The difficult part of this problem is figuring out what this included angle is between these two sides so that we can use the law of cosines. And that's why these little dashed lines help there too. We can see that this part right here is a 90-degree angle. And if this is 52 degrees right here, for 52 degrees west, that leaves 38 degrees to make up the 90 that goes here. And there's a couple ways to figure out that this is 29-degree angle. You can see that this is 61 because of alternate interior angles, or for the parallel horizontal lines, or you could use these vertical lines and say that 29 and this 29 are alternate interior angles cut by a transversal. Either way, you end up with the angle C is this 90 plus 38 plus 29. Okay, or angle C is 157. So now we have a triangle that we know two sides and included angle. So we can use the law of cosines to find the side opposite, which is the distance from the first airport to the second airport. So here's the law of cosines. The side that you don't know is opposite the included angle. That side squared equals one leg squared plus the other leg squared minus 2 times one leg times the other leg times the cosine of the included angle. And notice that the cosine of 157 will be a negative number. So this term is actually going to increase the distance that the hypotenuse would be if we were dealing with the right triangle. And that's expected because the included angle is obtuse. So I'll leave that to you to evaluate this. And then, of course, C equals the square root of all that. Okay, so enter that on a calculator, taking the square root, and then round off to the nearest mile. There you go. Hope that helped. If you have any questions, post a comment.